Well, welcome everybody. I hope the keynote this morning was fun and you managed to make your way up the escalators up here into the nosebleed seats up on the 4th floor. Let's see if the clicker's going to work on me. Okay. So my name is Paul Reed. I'm a product manager in our AWS Boston office. And we joined on stage today by David Green, one of our enterprise solution architects. David's going to do a demo. Everybody loves demos. And also joined on stage by Dan Boisvert, one of our customers, who's been helping us with AWS DataSync, preparing it for launch this week. We launched on Sunday night at Midnight Madness, for anybody who's up that late. Very exciting. DataSync really, at its heart, is a simple, automated, and accelerated way of getting data and moving data over the network from your data center into AWS or from AWS back to your data center. Whoops. We're going to tell you a little bit about why we built DataSync. What's the problem we're trying to solve? As you heard this morning in Andy's keynote, AWS, we're really customer obsessed. We listen to our customers, we listen to what you want. We've heard a need, we've heard a problem, and DataSync is here to solve it. So we'll give you some color on that. We'll give you some details about the service, how it works, how to get started, how to use it. Dan will come on stage and talk about how he's used it already and thinking about using it for some of the project he has going on at Cox Automotive. And David will come up and do a demo. Everybody loves demos, assuming they work and then Wi-Fi works and all that, so it's always fun, a little bit of excitement towards the end there. And then we'll take Q&A at the end. And we have stickers, so if anybody likes stickers, most people do, we have those. So what we've seen is as customers move more and more workloads to AWS, there's a need to move the data that supports those workloads. And while this sounds like a really easy problem, at scale, it's not as easy a problem as it might first appear. So what are the kinds of things you want to move data for? One that we hear a lot is migration. Customers on the cloud journey need to migrate applications into the cloud, and they need to move the data. They need to lift and shift the data from where it resides today into the cloud, into AWS. In many cases, that data is live. You can't shut down your applications. And so moving live data is kind of a hard problem, especially at scale. Again, once you move to terabytes or petabytes of data, moving live data can be a problem. Another class of online data transfer is for timely movement of data. So you maybe have something that's generating data in one location, but you want to process it somewhere else. So we see this a lot in various industries, healthcare, life sciences, media and entertainment, where you're generating data on a piece of lab equipment or a movie camera. You want to move it to the cloud for transcoding or big data analysis. And in that case, moving that data quickly is important to you because time is money, and the faster you can analyze it, the faster your business can get value from that data. The last use case is just you have data on-prem and you want to secure it, so you need to replicate it somewhere else. AWS is a great place to replicate that data to for disaster recovery and protection purposes. So how do you solve this problem today? So most customers, when they're faced with this problem, they say, okay, let's find somebody who's smart with scripting, and they start writing scripts. They start building a DIY solution. They get rsync or get some open source tooling. It's hard when it boils down to it. You have to write a ton of scripts. You have to ensure the data moves. You have to fire up workloads in the cloud to do data validation and checksumming. How do you secure the data over the network to make sure that your data doesn't get compromised? How do you manage routing between your network, which is nicely firewalled off from the unwashed internet, into the cloud? How do you get it into your VPCs in the cloud? How do you do it at scale? How do you fill those network pipes to move that data as quickly as you can? You've got to build infrastructure in the cloud, build infrastructure on-prem. It's just hard, time-consuming, and costly. So another way to solve this is to go out and find a commercial product that does this. Right? Somebody's got to solve this problem. So let's go buy something. What it turns out with those is there's still a lot of heavy lift. They're often not integrated with AWS services. Maybe they talk to file systems, but they don't talk to S3 object storage. You still have to worry about deploying that software, updating it, patching it, managing it. And again, it's complicated and costly to do it, even though you just paid for a software, an application that was supposed to solve your problem. So DataSync solves that problem. It solves moving large active data sets and adds into our portfolio of data transfer and hybrid storage services. On the left here, we have our online data transfer services. Things like S3 transfer acceleration, which helps you for S3 applications move data faster using our edge locations. Something like Kinesis for streaming data. Again, another service that we launched this week, Transfer for SFTP for your SFTP workloads. Then DataSync fills the last part of that column there for these online active data transfers. Again, for anybody that's gone to other sessions, we have our Snowball offering, Snowball and Snowball Edge, which allow you to ship data and give you some hybrid capability on the edge. Then lastly, on the right there, Storage Gateway, service that I've also been part of the product management team for 4 years now, which allows you to then access that data once it's in the cloud from your on-premises data center. So it's great to be able to move data in, but sometimes you still have applications that want to be able to access it, so we think of that as hybrid. So Storage Gateway provides that. Some of our demos and use cases today will show how DataSync and Storage Gateway work together really nicely. Again, solving a customer use case problem that you guys have told us about. So at its heart, AWS DataSync, it's about moving data online, fast and simply. We'll look at some of the benefits of the service. So we think of it, again, the tagline there, we think of it as sort of the speed and reliability of network acceleration tools with the cost effectiveness of open source. How does DataSync work? You deploy an agent on premises close to your local storage. So it sits on your secure network. Agents provided to you as a VM. You can deploy one of them. It can connect to multiple on-prem filers. We've built our own purpose-built protocol to move data between that agent and AWS, between our service endpoints in AWS. We'll talk a little bit about how that protocol moves data quickly in a moment. Our service in AWS is integrated with S3 and EFS to allow you to put data into our core object storage service and one of our core file storage services. You can move data out as well. When data leaves your data center, we encapsulate it in TLS to make sure it's secure. And the whole service is managed from the AWS console. So after you've deployed the agent on-prem, everything is done through our console or the AWS API's CLI. Let's dive into some of the nitty-gritty of what's within the service. Single agent will transfer data at about 10 gigabits per second. Again, bandwidth being available to it. You can deploy multiple agents if you need to move data faster. Mentioned we've built our own purpose-built protocol that we encapsulate in TLS. We play a bunch of tricks within that protocol, heavily multi-threaded. Again, that's the large combatant to latency on networks. Heavily multi-threaded, we take care of all that for you. We do things like data reduction inline, compression, sparse file detection, and a bunch of other things to reduce the amount of data that we have to send over the network, which all moves data faster. On the cloud side, we've integrated with S3 and EFS. We've built optimized mechanisms to get data into or out of those services as fast as we can. Again, we don't want our service to stand in the way of moving data. And as you'll see when David comes up in demos, oftentimes when customers are using the service, the limit is not our service. The limit is their ability to get data onto or off of their source filer. And for those that don't really want the service to go that fast because they're using their network for other things, surfing the web, looking at cat videos, streaming the keynote this morning, we do allow you to throttle or limit the amount of bandwidth that DataSync can consume, and we'll sit below that limit for you in order to share bandwidth nicely with other things. We play nice with others. Again, we want the service to be simple for you. We want it to arrive to you as a service, fully managed through the AWS CLI. There's no infrastructure in the cloud to manage. We take care of all that for you. Again, this is one of the pieces of sort of undifferentiated heavy lift that you have to do if you build it yourself or you go with a commercial offering is building and scaling infrastructure both on-prem and in the cloud to make sure you can move data quickly. So we take all of that away from you. We take care of that for you as part of the service. We take care of updating and patching the agents automatically. That agent, once it's securely associated with your account, will get software updates and patches to keep it secure and keep it part of the service, an extension of the service. And when we're moving data between storage services, we manage metadata between those services. So we make sure that the fidelity of the data is not lost, both the data and the metadata associated with it. And that's really important when we start to think about sort of moving files into S3 and then exposing them through things like File Gateway, and you're moving between different protocols. I talked a little bit about securing our data and using TLS. Again, one of the parts of building this yourself is if I'm moving data from where it sits today into the cloud, I want to make sure that data moves bit for bit. The data needs to go from A to B without being changed. We do a lot of validation, both in flight and at rest of that data to make sure that the data that is on the source arrives at the destination. I mentioned that we secure it in flight. We work with things like KMS for data stored at rest for doing encryption there. We work with our VPC services to make sure that when you're moving, say, to an EFS file system, which is secured within one of your VPCs, we put the data straight into that VPC so it can go straight to your file system. So the data never runs over open networks. And if there's a failure along the way, the network drops, or we detect a validation failure, we'll retry the data, and we'll make sure that what you asked us to move gets moved as quickly as possible without you having to get involved in retrying or handling failures. Like many AWS services, we integrate across some of our maintenance, monitoring, and management tools. So you'll get CloudWatch metrics to watch your data fly around, move between your source and your destination. You'll get CloudWatch logs to get more detailed view as to what data's moved and potentially any failures that happened along the way. We integrate with IAM for getting access to your resources in AWS, roles within your account that you control, so you control what the service can do to your AWS resources. And we produce CloudWatch logs so you can watch what the service is doing, watch what people are doing, what your users are doing with the service. And at launch, we're PCI DSS and HIPAA compliant for those financial services and healthcare workloads. We wanted to make pricing really simple. You know how much data you want to move, so we charge you based on how much data. No upfront fees, no minimums. Again, some of these commercial offerings have these minimums and commits. No, you pay for how much data you move. Super simple. You don't pay for any of the cloud infrastructure. We take care of all of that for you. We take care of the on-prem agents that you're running, making sure that there's no operational load for you to manage those in terms of patching and updates. So how do you get going with the service? It's a three-step process. First thing you'll do is you'll deploy an agent into your on-premises environment, and then you'll securely connect that to your AWS account. We provide the agent as a VMware image today, and you'll download that from the console with a fairly small footprint, 8 vCPUs, 32 gigabytes of memory. Data's never persisted within the service. It's always kept either in memory or on the network, so that VM doesn't need a lot of disk, because we're not storing anything. After you've got the agent up and running, you want to deploy that agent close to your local storage. It's going to use NFS to access your local storage. Fairly inefficient LAN protocol. We don't want to use NFS over the wide area network. So you'll deploy that agent. You'll configure a task. You'll give us the details of your NFS server so that agent can connect to it securely on your network, and the details of where you want the data to land in AWS. If you're going the other direction, you'll tell us where you want the data to come from in AWS and the details of your NFS server on premises that you'd like the data to land in. We think of this as a source and a destination. We have a bunch of options you can configure as well to determine what to change, what to transfer, and when to transfer it. We'll go into that in more detail when we do a walkthrough. And then you start the task and watch your data move. It's as simple as that. Let's do a quick console walkthrough. So we're straight on the AWS console/DataSync. Under the new migration and transfer services category, for anybody that's been to the console recently, we've done a little bit of recategorization of some of our services to make it a little easier for you to find them. You deploy an agent. Again, you download the OVA here, the VM image, configure an activation key that we give you that securely associates that VM with your account, and you've got your agent going. For anybody that's used Storage Gateway, it's a very similar pattern to how Storage Gateway deploys. Now that you've got your agent, you're going to configure your task. We walk you through every step of this to make it really, really simple. So the first thing you're going to do is select where do you want to move data from. Do you want to move it from on-prem to AWS, or from AWS back to on-prem? In this instance, we're going from on-prem into AWS, so we're going to configure the source location. So we're going to give it the details of the NFS server on premises. Now this is the local address of your NFS server. You're not exposing it to the internet. This is the agent that you deployed in your data center behind your firewall connecting to your NFS server. So you're going to give us the local details so that agent can connect and mount your NFS server. If you've used that NFS server before, we remember it so you can select previous locations. So you don't have to enter it every time. And a single agent can run multiple tasks. Next, you go on to configure the destination. In this instance, we're going to go into an AWS service. So we make that really easy for you. What AWS service do you want to go into? S3 or EFS? If you select S3, we give you a list of your buckets. You just select the bucket and you're done. If it's EFS, similarly, we give you a list of your file systems. You select the file system and you're done. Next screen being options. We'll go into those in a little more slide and talk a little bit about the kind of options that we provide that just let you control what data moves between the source and the destination to support those three use cases: migration, transfer, and replication that we talked about earlier. For anybody that's using AWS Console, we give you this nice review screen so you can go through and make sure that everything is to your liking and go back and potentially change settings if you choose. Then you hit create and you've got your task. Now that task sits there within your account and you can run it time and time again. And every time you run it, it's going to perform a sync from the source to the destination. So let's do that. Let's start the task. Go into the console, we see our task. We get a choice to override the options. Again, we'll talk about why this is important when we look at some of our use cases around migration. It selects the defaults that you selected during configuration time. I hit start and the task begins to run. When the task runs, he goes through a sort of a life cycle. Kind of important to understand what this life cycle is. The first thing is launching. So during the launching phase, what we're doing is we're initializing the task. The agent on-prem is reaching out to your NFS server on-prem to make sure you can mount him. In cloud, we're making sure we can connect to the storage service that you've configured as the destination, or vice versa if you're going in the other direction. Then we go into a preparing phase where we're looking at the source and the destination. We're figuring out what to move between those two locations. Then we go into transferring, where you'll start to see the data actually move. And then lastly, or second from last, a verifying stage, where we verify that what was on the source is in the destination. Now we allow you to turn that verification off. It doesn't change anything about the verification we do of data in flight. We're still verifying end-to-end at a sub-file level. But what that last verification stage does is it helps when you're doing a migration to make sure that at the end of this, the source and the destination are entire mirrors of one another. Now if you're doing a migration and your data set is active, and you know that your source is going to change, you may want to turn verification off for your first few syncs. And then when you're doing your cutover, turn it on to make sure that at the very end of this that there's no data left on-prem on your source location, and it's all in the cloud. And then finally, your task will either succeed or fail. If it gets a failure, maybe it's a verification failure, we'll give you a log of what failed within CloudWatch. And then if you like, you can start the task again. Tasks are incremental, always incremental forever. So if you move a petabyte one day and then you change a couple of gigabytes, we'll only move a couple of gigabytes the next time. Let's look at some of those task options that I mentioned that tell you what to move. So I mentioned that for migration, we have an optional verification stage that ensures that the source and the destination are complete mirrors at the end of the task. You may want to turn that off. If you know that the source is going to change, maybe you've got a log being appended or something, that you don't really care that the two are, there's an eventual consistency between those two. We select the file metadata that you want to consider for change. Some workloads, maybe you don't want to copy POSIX metadata into S3 objects for some reason. You don't want to mirror timestamps, or you don't necessarily want to mirror permissions over. So we allow you to turn that off. Again, very common with some of these command line open source tools. Mirroring file deletes is a good one. Maybe you don't want to mirror deletes on premises. We see customers that want to keep a small working set of data on site and copy all of their data into the cloud. Maybe they're building a data lake. And they want to delete stuff on premises because that's really their working set, but they don't want to mirror that delete over into the cloud. So we allow you to turn off file deletions, so we won't mirror those file deletes. And again, we mentioned bandwidth limits. We allow you to configure bandwidth limits in there. Let's look at the use patterns. So here we have this idea of migrating application data or live application data for a lift and shift, and Dan will come on and talk about how Cox Automotive are using this to take data they already have on premises and move it to the cloud. And this sort of becomes classic lift and shift migration where you potentially perform multiple syncs, multiple incremental syncs, and then eventually you have a cutover. So this is about moving active data. You want to make sure that the data is a complete copy. So the data validation side of DataSync is super important. And this idea of incrementals is really important because the data set on site, on premises, is constantly changing. And there's no real natural point where you could stop your applications writing to it and take a copy. Let's look at the second use case, this idea of transferring. We see this a lot. We're working with a number of companies that are doing things like gene sequencing or in the M&E media and entertainment space where they have data that they're generating on site. And for those companies, the idea of getting that into the cloud and processing it quickly is really, really important. And either it's a time is money discussion where the faster they can process it and get results from it, the faster their business can derive value from it, or they just don't have enough storage on-prem to keep stockpiling it. And so the faster they can move it into the cloud, the faster they can delete it from their on-premises storage, and therefore the smaller the footprint of their on-prem storage. So again, this idea of securely, again, in some of these industries, this data is very sensitive data, it's IP, so this idea of securely and reliably moving this data, the cost to regenerate that data in some cases is more than the value of the data rather is more than the cost to transfer it or more than the cost to store it, so they want to make sure that the data gets moved reliably and quickly. Then the last third use case is this idea of replication. So we have a timeline across the top. As your data set grows, as your files change, you want to be able to replicate those into the cloud for backup or disaster recovery purposes. So by running DataSync periodically, he'll keep copying the incremental changes, minimizing any potential loss if your data center was to have a catastrophic failure. Data is always stored in the cloud based on the last time that you ran sync. I mentioned storage gateway and file gateway in particular, and this use case is around reducing your on-premises footprint. So maybe you have a filer that's reaching end of life, or that you're running out of space on, and you'd really like to move that data to the cloud. It's cold data, the working set is small, so you have your NFS server on site. You can run AWS DataSync behind it, which will now start to replicate that data up to S3. Again, it'll just keep replicating it every time you run it. Incremental transfers, as your applications change data, Sync will take care of putting that into S3 for you. You can then spin up a file gateway, another thin provisioned VM, which can access that same bucket. You can switch your applications over to file gateway, just repoint them to file gateway. They have access to all of that same data now through file gateway and through the caching capabilities of file gateway. And then you can just decommission your on-premises storage and effectively replace your large, power-hungry, cooling-hungry NAS with a thin provisioned VM with all of your data securely stored in the cloud. The nice bit here is your applications really don't see any difference, but now all your data is in S3, so all that ecosystem of tools and products that work on top of S3, you can bring them to bear on that data to get additional value out of it. Meanwhile, your on-premises applications are still going about their merry way. So again, just to sort of compare and contrast, DataSync helps you get that on-premises data into the cloud, into S3 or EFS. File Gateway then provides you access to that data through its caching layer back on-premises to those applications. So I like to think of DataSync as a client to your existing storage and File Gateway as a server to your storage in the cloud. I don't see anybody nodding, but that's how I like to think of it. Okay, enough from me. I'd like to invite Dan Boisvert up onto stage. I think we've probably kind of tangentially worked together now for a couple of years. Dan was one of the early adopters of File Gateway when we launched that at reInvent 2 years ago. And working with him and some of his needs was kind of one of the genesis of how we started to think about maybe File Gateway and DataSync are this pairing of offerings that can help Dan solve his problem. But he'll tell you about that.
I sure will. Thanks, Paul. Hello, everyone. My name is Dan Boisvert. I'm a lead site reliability engineer at dealer.com/Cox Automotive. There's a slash in there because it's kind of a large umbrella organization. Cox Automotive has this global vision of transforming the way the world buys, sells, owns, and uses cars. Most of our clients are car dealerships. Fortunately, I don't have to work with all of them individually. We have something like 40,000 dealership clients in North America. If you look on the slides, you can see some of the brands that we represent. How many folks here have bought a car ever in your life? Anyone? All right, cool, good. How many folks have seen, for example, an Auto Trader ad on the Super Bowl? You usually see them at halftime, see a couple of folks, maybe not too many football fans. Okay. How many folks have ever looked for a used car value and have looked at the Kelley Blue Book? A few more hands there. Cool. And how many folks have ever looked at a car dealership's website, whether you're looking for hours, see what they have in inventory, make a service appointment online, any of that sort of thing? Awesome. So that last group of folks have probably used our stuff. Our stuff meaning the stuff that I'm personally responsible for at dealer.com. So dealer.com is based in Burlington, Vermont. We have about 1,400 people there and have grown from a company of 5 founders 20 years ago to 1,400 or so now. And one of the primary things that we do are automotive websites. So you'll see, numerous of these. We host many of them, 60+% of the market for franchise dealerships in the United States currently. And all of these services are all white labeled, right? So we're a SaaS provider, we're extremely multi-tenant, and we weren't always big. 20 years ago, we were 5 people in a garage, and literally last week, I think, was our 20-year anniversary. So we didn't necessarily always build things in, the best way. Sometimes startups are poor. But the guidance that we're getting currently, right, is we have, we really want, empowered teams. We want teams to be able to execute autonomously. We want to make it easy to do the right thing. We don't want people to do the right thing because we tell them to. We want to really provide incentives that make it easy, right? And so one of the things that helps to reinforce that is setting up the right incentives, where you have, DevOps, for example, is a wonderful one, where if I write crappy software and it pages somebody in the middle of the night, the person who's getting paged is me, and therefore I have a lot of incentive to fix it, right? I can't just rely on this ops guy who sits over the wall, and that person gets paged, and so I get kind of indirect feedback, when I get a grumbly email or something in the morning. And we really try to make it, easy to do the right thing, and also at least marginally more difficult to do what we consider to be the wrong thing. So, the current guidance that we're receiving is move everything to AWS. You've probably seen in different places that Cox Auto is going all in on AWS. We also think it's quite good for our business for a variety of reasons. We want to use PaaS wherever possible. We don't want to build things, or at least not things that other people have already built. Right? I mean, we can all, collaborate on having, paying Amazon to build, a specific service, and all of us can consume it. And so we both get a service that's probably, or we all rather, get a service that's probably both better and cheaper than what we would write, if we were each creating our own, right? So again, for folks here, this probably isn't that much of a surprise. But we want to take that, even in cases where PaaS costs more, and take that time savings and have our own engineering teams building things that really adds value for our customers. And we want to let that use go faster, right? So the use case that you're about to hear about is pictures. So if you've looked at a website on the internet, a lot of them have pictures. Some of them might still not. But if you're looking at automotive websites, we have a lot of pictures. And so as somebody who hosts 60+% of the car dealership websites in the United States, we have something like 700+ million, photos that we use for display on our websites and for marketing and a variety of other things. So there are a few different categories of these. In some cases, they're VIN-specific imagery. So, when a car dealership gets a car on their lot and they go and take pictures of them and they upload them to the website so that, all of their car shoppers can go and, see what the car looks like, especially useful for used cars, right? You don't want to buy something if you can't see what kind of condition it's in, especially if it's pre-owned, and you're not going to get the same warranty. And we also have, there's of course stock photos, and there's, all the photos of, your friendly dealership staff's, faces, right, when in the About Us section, as well as all the usual, navigational stuff and all that. But in aggregate for our platform, we're looking at upwards of 700 million photos. Our 3-day working set is over 220 million photos. And many of these photos aren't actually served that many times because ideally cars don't stay on dealership lots for very often, right? Or for very long, excuse me. So they come in and then they go out actually fairly quickly. And so we churn a lot of photos. Between 1 and 2 million objects per day are coming in and out of our systems. So they come from a variety of sources. And, as the company grew, we had ways of managing that problem, right? The old way, you can see here, we had piles of NetApps. It started as one, and then we ran out of space, so we added another one, and then another one, and another one. And as things grow, right, when you're in startup mode, you don't immediately scale to infinity. You start off and you kind of grow as your needs do. And so, we're also a bunch of engineers, and we needed an image transformation service, right, to do resizing and various manipulations and that sort of thing. And so, well, we're engineers, and we need a thing, and engineers build things, so we'll just build one, right? And I'm not sure how many of you folks have taken the AWS developer certification class, where they actually go through image resizing using Lambda at the edge as like a stock template example. Anybody taken that class? No? 1 or 2. So I actually met a lot of junior engineers when we had AWS on site to do that class for us. And they're like, oh, hey, I just learned this thing and we can solve all of our imagery problems. I just learned this thing in class. And they all came by to my desk to tell me that, we didn't need to do it the hard way anymore. We could just do it that way instead, which was wonderful. It was a great way to meet people. And in order to get all these files into our systems, all of the writes were going via NFS. We had many readers via NFS, some also, of course, using the web endpoint. And so it really, got kind of messy, And when you're in this position as a startup, you're growing, somebody needs access to your data, some other team, they're coming in and, well, here it is. And then next thing you know, you have a swamp, right? And nobody likes a swamp, but sometimes you end up there anyway. I imagine most of the folks in this room have probably had similar issues. At some point, there's some system that you can think of right now in your company that isn't quite as clean or neat or wonderful as you'd like it to be. And so, when you have systems like that and you need to make them faster, you just add layers of caches, right? You just cache all the things in all the places, and you have, as you're scaling up, you have more customers and more customers and more traffic, and periodically you get DDoSed because somebody gets pissed off at one of your customers and decides to send them a lot of traffic. You just add more caches. Well, that's great until you end up with, dozens of caches that are all hard to purge, and, it really becomes an organizational nightmare. So we wanted to do something better. The pressures in the market for us as a SaaS provider are that our market is extremely competitive. We have competitors who would love to come and steal all of our customers, right? And so if we want to keep those customers, we have to make sure that we do a good job of serving them. And a lot of the demand that we were getting from customers is for higher quality imagery, right? Prettier pictures. And for shoppers, if you're looking at a used car on the internet and you can't tell if it has any scratches on it, is that useful to you? Probably not so much, right? You would be much more likely to buy a car online if you can actually see what it looks like. That's kind of a strange concept, right? So how do we do this, right? We want to manage this with the number of objects that we're talking about and the amount of churn. There's a significant footprint that we need to be able to scale this and actually run it at an acceptable performance level for our customers. And so Amazon has this great storage service. We want to be able to put this in S3. We decided to take that image manipulation that we were doing before and move it into our CDN. We use Akamai for CDN. They have this cool image manager product that actually does real-time transcoding on imagery. And so it actually sends different file formats to different browsers based on what's most efficient. And there's a bunch of fancy compression stuff that it does. So we wanted to do that, get out of the business of maintaining our own resizer and pay somebody else who's going to do a better job on it. We wanted to have a web service accept all the rights so that our developers were free to iterate behind a strong contract. We try to do that everywhere else in our services, and certainly we're in need of it here. We wanted to be able to access this from all of the writes coming in through that one point, and be able to have all of the reads coming in through the HTTP endpoint. Seems like a simple thing, but again, you need to get a lot of other people to update their stuff to make it happen. And then we wanted a simple cache hierarchy that was easy to understand, easy to troubleshoot, easy to reason about, and really know what was going on. So the biggest challenges that you have, or at least that we experience with a project like this, is actually finding all of the producers and consumers. When you do these integrations at the data store level, in your business, you may have seen this either at the data store, either NFS, or perhaps shared databases. When you have a ton of teams and a ton of services all hitting these things at the same time, figuring out who all is consuming it and who all is producing into it becomes a real task. And if you can untangle that, the rest of this problem is actually quite easy. So, that's going to be your job 1. It's probably going to also be your job 3, your job 7, your job 12, as you find more people who have, some periodic job that mounts an NFS volume, dumps a bunch of data on it, unmounts it, and they do it, once a quarter for some super important client, right? All of the real-time, traffic monitoring that you do over the course of a week or a month is not really going to help you here. And then, really making sure that you hit the SLAs that you need for whatever your new service is going to be. Especially when you're looking for some sort of hybrid state, right? You can't necessarily go directly from your current state to awesome. Sometimes you have to go through this intermediate term state, right? And that's really, I think, where the strength of File Gateway and DataSync really come in. They really make that intermediate state something that you can survive for long enough to get everything into a cloud-native pattern and really get your data up there where you can do the things that you want to do and have the freedom to really run. So if you're going through to actually do this step yourself, step 1 that I would strongly recommend is find somebody in perhaps an expensive outfit in an expensive office and make sure that they back you on this. You're going to have to ask a lot of people to make changes to their services. And some of those teams are going to tell you that, well, hey, we'd be glad to make that change, but we're booked out for the next 3 quarters, so, how about 9 months from now? And you're going to get that from people, right? I certainly did. And so, as we were going through this process, really getting that buy-in from people high enough up in the organization to pull when I couldn't bribe people with beer to get my work in was really important and valuable. The next thing to do is really make sure that you update all of your readers to consume through whatever your new read endpoint is going to be. If you start writing directly to S3, but all of your folks are still reading via NFS that's still on-prem, that doesn't help you, right? Because your readers can no longer consume the data that they need because you moved it on them. So you really need to make sure that you get the sequencing correct and that to make that work. The next thing you need to do is really make sure that you test the crap out of this thing, right? You're putting really important data on there. It's extremely valuable to you, to your customers, and you want to make sure that all of these things are going to perform the way that you expect, both from a performance perspective as well as a reliability perspective. You need to make sure that you can hit your storage SLAs, right? If you're moving storage, frequently applications just expect that storage is always going to be there and always going to be awesome and performant, and they don't really think about it. So you want to make sure that you know what their expectations are and that you hit them. And then the next thing that you're going to want to do is you're going to want to take an initial data sync, right? Make that first copy. The first time that you take that data and you suck it up into S3 and you can actually see it there, then now you can start running those incrementals and finding out, all right, how much of this data set is changing on a routine basis? If I run this thing every day, how long does it take? And then once you do that, you can figure out, okay, cool, so now I know that I'm going to need a 3-hour window to be able to do this incremental sync, and now I can schedule a maintenance window. Right? Ideally, you can take this thing down for a few hours, whatever it is. If you find that you have such an enormous data set that you can't do it, inside of any sort of reasonable maintenance window, you can start breaking up the data set into subsets, right? You can start, migrating subdirectories and creating symlinks over to the new location or however you want to do it. There are a variety of strategies. But the thing that I'd really like to emphasize is that the speed of data sync gives you a lot of agility because you can move data a lot faster than you could before. We were playing around with a variety of different options in order to migrate this data set. And the hundreds of millions of tiny files data set is always like kind of a crappy one to work with because everybody's like, yeah, everything works generally pretty well, but on that data set, that's really troublesome, right? It's always a pain to work with. And DataSync works great with it. So we were really pleased to have something that would do that for us. So what are we doing for that near-term plan? S3 buckets in multiple regions, image manipulation using our CDNs tooling, file gateway accepts writes, all reads to the web endpoint, and a simplified cache hierarchy, right? And so there might be one difference from here from our actual desired end state. Anybody know what it is? You can probably see it behind me. Really just the write location is different. And the cool thing about having file gateway there is that anybody who expects to be able to write via NFS today can continue to do that tomorrow and next month and next quarter, and they're fine. So you can actually start gaining, in the intermediate phase before you're in that, end state perfect happy cloud phase. And we think that's really valuable. So for the technical bits that you're probably going to care about in order to make this work for you, your storage is likely going to be your limiting factor for data sync speed. So Paul mentioned earlier that you can sync it up to 10 gigabits per second. I knocked over a NetApp way faster than that with this workload. So, because this workload this data set is fairly, I'm going to say I/O unintensive. It doesn't tend to get put on like the newest, shiniest, all-flash, filers that we have, right? So the first time I ran this, I got our storage team paged. I knocked over a filer. The application team that used it wasn't actually super thrilled with me either. It came back up quickly once I canceled the job. But I'm not actually used to working with things that are fast enough to cause me this problem. So you can use the network throttling feature to do that and to say like, hey, slow down. I actually want to make sure that I don't knock over my storage, the first time I run this thing, which is a wonderful problem to have. To be able to say like, oh, my data synchronization utility is too fast is fantastic, right? And that buys you that agility to be able to move faster and not have your projects drag on for months and months. Instead, you can do things in days or potentially weeks. The other thing that this buys you is that if you have 95th percentile billing on your circuits and you're not paying for a full 10 gig commit or whatever on a 10 gig circuit out of your data center, if you can fit your data synchronization in less than like 36 hours or whatever it is, you can actually fit it inside of your monthly bill without changing your network bill and like ship all your data up there inside of that window. So there are some things here that speed actually buys you, where if you were syncing at 2 gigabits per second, you couldn't make it inside the window, so you double your network bill. But if you can sync at 10 gigabits per second and you can fit it inside that, that 5th percentile that you don't have to pay for, you could actually get your data up there way faster and save a bunch of money. So that's something else to consider as well. If you haven't looked at File Gateway in a while, it's really good at mixed workloads now. Paul and I first met a couple years ago when I was banging on this initially, and at the time it wasn't as good at really abusive workloads like ours, and it is now. So if you haven't given it a look recently, I would strongly recommend doing that again. And in order to really make sure that you accommodate your workloads, the file gateways have a couple of different buffers, right? So you've got the read buffer and then a write buffer. And you want to make sure that you size those appropriately to your workloads. You publish stats on that through CloudWatch, so you can actually watch your cache utilization rates and churn and see how full they are and that sort of thing, and make sure that you can actually keep up with your data. And then really, really, really remember your SLAs. Know what your performance SLAs are. Know what your reliability SLAs are. Is your VMware environment reliable enough to be able to put a storage appliance on it and meet your storage SLAs? Maybe it is, maybe it isn't. If you lose hypervisors all the time, maybe you don't want to use that pattern. Maybe you want to use the hardware appliance that they've got for this thing. Or maybe you want to have two of them, and if one of them fails, you want to swap the other one in real quick, right? I mean, there are a couple of different options that you can use for that, but you really want to make sure that you think through those problems. So what did we end up with? Prettier pictures on websites. That part's pretty cool. Reduced management burden, because we don't have to have people dealing with on-prem storage anymore. We don't have to deal with handling an on-prem image resizing application that it's kind of gotten old and riddled and people don't want to touch anymore. We sleep better because you can put this data in US West 2 and US East 1 using the cross-region replication thing, and not really have to worry about it as much. With S3 being as durable as it is, and versions and lifecycle policies and all that, you can make a much simpler, much more resilient structure than you could before. And then it turns out that in trying to make this better, we accidentally saved a bunch of money. So the image resizing stuff that we bought from Akamai actually was so much more efficient at compressing our imagery that we saved more money in bandwidth than it cost us for the product. So when you're looking at certain ways to improve efficiencies and that sort of thing, look at stuff like that. It's actually really valuable because all of our car shoppers are also now getting their imagery much faster. So web pages are faster, they're prettier, we're saving money, plus we don't have to maintain our own on-prem resizing application anymore. That's pretty cool. And then also, of course, there's a storage aspect where, when you move things out of on-prem storage into S3, we're figuring that it's probably going to save us about 85% on our storage. So in summary, you can try to start off by making things better and accidentally also make them significantly cheaper. Whoops. So David's going to come up now and show you how this thing actually works. This is the most exciting part of our talk today. Hopefully the Wi-Fi will work out for him.
Hey everybody, I'm David Green. I'm a enterprise solutions architect here at AWS. I'm based out of Los Angeles, so based out of LA, I'm heavily focused on the media and entertainment workloads and the major studios in LA. One of the common things we hear is, how do we move data as quickly as possible up to S3 or EFS for processing or data access on the cloud? So typically, the customers that I work with have license options, so they have third-party commercial software to do this. They use it on-prem already, and they kind of shifted that to the cloud. And we see some scenarios where maybe it's cost prohibitive, or it's transient, where they're doing production, maybe data acquisition for a few weeks or months in a location. And they want to move that data quickly in for dailies and processing, but it's just it's a lot of money to buy these things. So basically, moving large data is easy. I have both cases here, but I really want to show something that's more challenging is moving small files. So I have a public data set on a NAS server in a data center. The public data set, of course, is cat photos. I mean, there's lots of car photos on the internet, but cat photos is a lot of these. I have 1 million of these. The data set's not giant. It's 193 gigabytes in total size. Average size per file, it ranges, but average is 200 kilobytes. And I was doing 2,632 files per second, and this is off a single 1U NFS server. It's nothing fancy. It's not a full commercial NFS server. It's just a regular 1U Linux NFS server. And that was pretty mind-blowing for me because I was not expecting that throughput. Then the total job finished from when I hit start on the job, when it started the job and scanned the files I have to move, and move the files, it finished in less than 7 minutes. Here's what the graph looked like. So the top graph is the NAS server, and the bottom is Direct Connect. In the data center there, I have 2 Direct Connect circuits, and it's configured to use both as equal cost. So we're actually spraying traffic across both links. So if I zoom in, I didn't quite hit the full 10 gig capacity, but still just doing a high number of IOPS off a single 1U server. And I did the same copy of the exact same data set using traditional open tools. And when I scroll over, you can kind of see a little bit of a bump, and that's what it was. And if I zoom in on that, you see it's less than 100 megabits per second of throughput. This is what the GUI looks like as well. So we see that this transfer just nearly done there. I have just shy of 1 million files, and the duration there is under 7 minutes. In the data center, this is what it looked like. I had a NAS server. I had a directory that went to S3. I had another directory also, another task that went to EFS. So in some cases, maybe I want to have data go to S3, and then others I want to have a subset go into EFS, whether I have processing on cloud that requires an NFS mount point. I'm also replicating data to another region. So we have use cases where data is acquired in one location, and then you can use cross-region replication with S3 to actually ship it to another region of the world. And it's accessed using storage gateway there. And this is 10 gig direct connect. And this job was done with a single DataSync agent. As Paul mentioned, you have more than one agent. This is a single agent doing this task. Here's what the topology looks like. And I'm replicating to Seoul, South Korea, into an S3 bucket. I'm also using a lifecycle policy to tier into Glacier. And data access is done through NFS gateway, or file gateway using NFS protocol. And what's interesting now as well, with the recent announcement with S3, we can do a S3 direct put into Glacier. So if you write data into S3 bucket, you can have a cross-region replication policy that does a direct put into Glacier without having a lifecycle. Direct connect, super easy. Basically have 2 connections, and I enabled multipath on my Juniper router, and that basically treats both as the same cost. So it affords for not only a failure of a circuit or maintenance on a router, but also it can use the full aggregate bandwidth of both these circuits. And here's what it looks like in real life. So I'll switch over here real quick. Oops. Oops, sorry. Yeah, I'm trying to hit 2 right now. It's not clicking. Cool, thanks. Thanks. So here's a task I did just before coming up. This was launched at 11:23 today. This is just over 1 million files transferred. Again, the public data set of cats. And as you see, here I'll show you this as well. This is what it looked like. So it's the same each time. It's super fast, and it's really impressive. Something else I wanted to show you as well. The DataSync task is writing into S3 bucket, and then I'm using file gateway with S3. And here I transferred a larger data set. This is using the ARRI Alexa camera. It's Alexa 65, which generates 6.5K resolution, so it's basically 6,500 pixels across the top. I had this is a GPU-based remote workstation on EC2, and I'm using the GPU to actually render these out into smaller size JPEGs that are easily played back for viewing purposes. So this is a popular open source player called DJV, and this is playing off NFS through file gateway on a GPU-based workstation, like easily through my laptop. And we see customers use this as well for remote workstations. Maybe they have artists that they want to bring in for short times. It's really easy to have super high power EC2 instances with the latest GPU technologies deployed on demand. And when you're done, just turn it off and you're done using it. So this is really easy for us now to be able to move data quickly. And I always liked being associated with this because my customers are always demanding, like, how do we do this faster? and how do we move data from multi-10 gig circuits into the cloud for processing and across the world for our distribution partners and collaborators. And now it's a lot easier to do. So thank you.
Is it going to go back?
If we switch back to the other one.
Can I have the clicker? Thanks, David. So as you can see from both David's demo and some of his experience with some of his customers and Dan's experience trying to move storage from his current on-premises infrastructure into the cloud, DataSync is a pivotal part of that whole story for many customers and many opportunities. So we think of it again as a service to simplify and automate your data movement for migration, transfer, and replication. Number of benefits. Again, if you're looking to do this and you're thinking about DIY, thinking about commercial alternatives, I encourage you to give DataSync a go. Give it a try. We're available in 10 regions as of today, and we're going to expand as we go into 2019. And for anybody who'd like a sticker or anybody who'd like to learn more, there's the URL. And please, if you have any questions, I'm more than happy to take questions, either live on mic or if anybody wants to come up one-on-one, I'm happy to do that as well. Thanks for coming, and I hope the rest of your reInvent is awesome.